Given sine of x is equal to -1/4 and angle x is in quadrant 3, what is the exact value of cosine of x in simplest form? Simplify all radicals if needed. Now, one thing you got to know about this problem, you got to know the Pythagorean trig identity, which states that sine squared theta plus cosine squared theta is equal to 1. Or in this case, sine squared x plus cosine squared x is equal to 1. Now, the reason you got to know this is because, once you know this, it's pretty simple, right? You know that sine of x is equal to -1/4. So you just plug this into the formula, you solve for cosine of x, and, everything's good. And the reason why this formula kind of exists is because, well, if you have your unit circle, right? If you have a unit circle, let's say I pick any point out here. Let's say I pick this point, right? This point on the unit circle. And I create an angle, right? I create some sort of angle theta where this ray right over here intersects this unit circle at this point. Now, if I draw an altitude downwards and the altitude creates a right angle, well, all of a sudden we have this angle and we have this, right triangle here. Now, cosine of theta, well, all right. Let me just write this out first. Okay. So you can all agree that this part of our triangle right over here represents the x value of this point, right? This point, whatever the coordinate this point is, right? Let's actually say if this coordinate right over here is x comma y. This point has coordinates x comma y. You can all agree that this value right over here represents the x coordinate, right? And you can all agree that this value right over here represents the y coordinate of this point. And because this is the unit circle has a radius of 1, right? The circle has a radius of 1. Now, cosine of theta is equal to adjacent over hypotenuse, so it's equal to x over 1. Sine of theta is equal to opposite over hypotenuse, so it's equal to y over 1. So cosine of theta is equal to x. Sine of theta is equal to y. So instead of x right over here, I can replace this with a cosine of theta. And instead of y, I can replace this with sine of theta, right? Because just said how they're equal to each other. Notice how this is a right triangle, so you can do the Pythagorean theorem. So we have a squared plus b squared plus b squared plus b squared is equal to c squared. And this is where the formula comes from, okay? Right, a squared plus b squared is equal to c squared. 1 squared is just 1, so that's why I just wrote the 1 here. If any of you guys are confused, cosine theta squared, like this, you can write it like this. So these two things are equal to each other. If you write cosine of theta squared, that's equal to the same thing as, it looks like cosine squared theta, right? These two things are the same thing. The reason I write it this way is just because it's easier, but there's no difference. All right, anyways, given that sine of x is equal to -1/4, angle x is in quadrant 3, what is the value of cosine of x? Well, knowing this formula right over here that we proved, or these two formulas are the same thing, I just kind of swapped the order, but now that we know this formula is true, let's just substitute this in. So I'm going to get -1/4 squared, right? Sine squared plus cosine squared is equal, cosine of x squared is equal to 1. Right, because we're dealing with angle x in this case, not angle theta. So -1/4 squared is 1/16 plus cosine of theta. I keep saying theta. Cosine of x, and this is equal to 1. I subtract 1/16, so I'm going to get cosine squared of x is equal to 15/16. If I take the square root of both sides, I'm going to get cosine of x is equal to plus or minus the square root of 15/16. Well, the square root of 15, you can rewrite this as the square root of 15/4. Right, whenever you have a radical like this, and let's say a divided by b, this is going to be equal to the square root of a over the square root of b. So if I have radical 15/16, I can rewrite this as the square root of 15 over the square root of 16, but we know the square root of 16 is equal to 4, so I just wrote that. Now we have this plus or minus here. How do we do this? Well, there's a big hint. Quadrant 3. We said how angle x is in quadrant 3. Whenever you're doing these types of problems, look at the quadrant, all right? I want you to box the quadrant whenever you're doing these problems. So what this problem is telling me is that whatever our angle is, our angle is going to be in quadrant 3. So whatever angle that we create, it's going to be in quadrant 3. This is angle X. So we have angle X, and it's in quadrant 3. Now notice how in quadrant 3, every X value is negative, right? Every X value is negative. No matter which point you pick in quadrant 3, right? Every X value is negative. So in this case, we're actually going to stick with the negative answer. Remember, we said how, in the beginning of the video, we said how cosine of theta is equal to the X value. So if quadrant 3, if all of our X values are negative, well, cosine of theta cosine of X has to be negative in this case. So in this case, cosine of X is going to be equal to negative square root of 15 over 4. All right, so here's like a little cheat sheet to help you. So when you're in quadrant 1, both your X value and your Y values are positive, right? Both your cosine value, both your sine values are positive. In quadrant 2, your X value is going to be negative, right? If you create any angle here, your X value is going to be negative, right? But your Y value is going to stay positive. If you create an angle like this, where it's in the third quadrant, well, notice how both your X value and your Y value is going to be negative. So here, and then finally, in the fourth quadrant, your X value is positive, but your Y value is negative, right? I create an angle like this. The X value is positive, right? It's positive, but your Y value is negative, right? It's below the X-axis. So let's do another problem. Let's say that in this case, if we're given cosine of X is equal to, let's say, 3 over 8, and we want to find out the exact value of sine of X, and this is in quadrant 2. All right. So feel free to try and do this problem using this right over here. Well, if cosine of X is equal to negative 3 over 8, well, let's plug this into the formula first, right? If we're given a cosine value and we're trying to find a sine value, well, we are going to use this formula, Pythagorean trig identity. So we have cosine of X is equal to negative 3 over 8, so we're going to have negative 3 over 8 squared plus sine of X squared is equal to 1 over 8 squared. That's going to be 9 over 64 plus sine of X squared is equal to 1. When you're squaring this like fraction, you can sort of think about as, you square the numerator and you square the denominator. So 3 squared is 9, 8 squared is 64. 2 negatives make a positive. So that's where I get the 9 over 64 from. Bring this to the other side. We have sine squared X is equal to, that's going to be 55 over 64. If I take the square root of both sides, I'm going to get sine of X is going to be equal to plus or minus the square root of 55 over 8. All right. Now, this says that our angle is in quadrant 2. And remember how we said in quadrant 2, our X value is negative, but our Y value is positive. So in this case, since our Y value is positive, we're going to stick with the positive answer. So sine of X is equal to positive square root of 55 over 8. And that's going to be our answer. Notice how for this problem, our cosine value is negative, our sine value is positive. So it matches up with what the graph was kind of saying. Finally, we got 2 little quick things to kind of mention. So remember your reciprocal trig functions? Well, let's put them to use. So right now we have the Pythagorean trig identity. And what I'm going to do is I'm going to divide the whole equation. So I'm going to divide basically every single term here by, first of all, I'm going to divide all the terms by cosine squared theta. So let's say I divide the whole equation by cosine squared theta. And because I'm dividing at the left and the right side, this is still equal to each other. So cosine squared theta, they cancel out to be 1. Sine squared theta divided by cosine squared theta, well, another important trig identity to know is that sine of theta over cosine of theta is equal to tangent of theta. Now the thing is, if I have sine of squared theta divided by cosine squared theta, I can rewrite this as sine theta over cosine theta squared, because of the exponential property. So if you remember your exponent properties, well, one property is that if you have a squared divided by b squared, this is going to be equal to a over b squared. For example, if I have, let's say, 3 squared over 4 squared, this is going to be equal to 3 over 4 squared. So, in this case, if I have this squared divided by this squared, it's going to be this whole thing squared. And we know sine over cosine is equal to tangent, so let me just substitute that in. So we have tangent squared of theta, so we have tangent squared of theta, and this is going to be equal to 1 over cosine squared. Well, if I know that 1 over cosine is equal to secant, well, 1 over cosine squared is going to be equal to secant squared. Secant squared. 1 plus tangent squared theta is equal to secant squared theta. Now, the second thing I'm going to do is I'm going to divide the whole equation. In this case, I'm going to divide this whole equation by sine squared theta. Now, if I know that tangent is equal to sine over cosine, well, that means that cosine over sine of theta is going to be equal to cotangent of theta. Because think about it, right? We're talking about reciprocal trig functions. So the reciprocal of sine over cosine is going to be cosine over sine, right? And we know that the reciprocal of tangent is equal to cotangent. So cotangent must be equal to this because it's the reciprocal of tangent, right? If you substitute tangent of theta in this equation of sine over cosine, you'll find out that you still get the same thing. So cosine theta over sine theta is equal to cotangent of theta. So this right over here is cotangent of theta. Sine, all right, this is just equal to 1 because it just cancels out. And 1 divided by sine theta squared, well, that's cosecant of theta. But except we have a sine squared theta, so it's going to be equal to cosecant of theta squared. And that is our second identity that we've gotten from just Pythagorean trig identity.